Hello doctors, this class is about HMP Shunt Pathway. You know very well the glucose always enters into cell for glycolysis, for energy production. But a minor amount of glucose enter into a shunt pathway that is called as exose monophosphate shunt pathway. So glucose is usually oxidized to give ATP through glycolysis. So glycolysis, it produces ATP for energy production, but it also enters into a minor pathway called HMP Shunt Pathway. Why it is called as exose monophosphate, HMP Shunt Pathway? In glycolysis, all the intermediates are biphosphates or bisphosphates in glycolysis, whereas in shunt pathway all your intermediates are monophosphate. That is why it is called as exose monophosphate pathway. Why should it be called as pentose phosphate? Because one of the product of the shunt pathway is ribose. That is why it is called as pentose phosphate pathway. Also, this shunt pathway can be named as direct oxidative pathway, because in glycolysis it won't give carbon dioxide. For carbon dioxide to be produced, glycolysis has to enter TCA cycle for complete oxidation to produce its carbon dioxide. But in the shunt pathway, it can produce the carbon dioxide directly. That is why it is also called as direct oxidative pathway. One more important thing is, in this pathway, no ATP is produced as well as no ATP is utilized. This is the importance of HMP Shunt Pathway. So, where it is located? It is located in the cytosol of the tissues. That means all the metabolism of HMP is going to take place in the cytoplasm, like your glycolysis, and also in the tissues which has high rate of proliferation, active fatty acid and steroid synthesis. Where you can find the active fatty acid and steroid synthesis? In the adipose tissue, lactating mammary gland, adrenal cortex. So, it is synthesized in liver, adipose tissue, lactating mammary gland, RBC and adrenal cortex. So, this is the location where the HMP Shunt Pathway is going to take place. So, the number 2 is very important when HMP Shunt Pathway is considered. Like the functions, there are 2 major functions, and phases, there are 2 phases. So, what are the 2 major functions related to HMP? One, it can produce NADPH. So, it is very important for biosynthetic reactions of fatty acid, cholesterol and steroid synthesis. One more thing, it produces pentoses. These are the 2 major functions concerned with the HMP. And what are the 2 phases? It has 2 phases. One is irreversible phase and another one is a reversible phase. Irreversible phase is oxidative phase and reversible phase is non-oxidative phase. From the name itself you can understand, I've said in the previous slide that it will produce carbon dioxide directly in the shunt pathway. So, it is going to happen in the oxidative phase. Irreversible oxidative phase will give your carbon dioxide. So, there is also a minor function concerned with the HMP. It is nothing but it also produces trioses and hexoses, which are required for your glycolysis. So, these are the 2 major functions and 2 phases seen in HMP. So, first we'll see the irreversible oxidative phase. In this, two things are happening, dehydrogenation and decarboxylation. So dehydrogenation reaction is otherwise the oxidation reaction. This oxidation is coupled with decarboxylation. So it is called as oxidative decarboxylation is happening in the irreversible oxidative phase. During oxidation, in glycolysis, it produces NADH. Okay, in glycolysis, it produces NADH. Whereas in HMP, it produces NADPH. This reduced coenzyme is required for biosynthetic reactions of fatty acid, cholesterol and steroid.